I'll going to discuss some more important topic discussed from module 3, embedded system components, and some of the comparisons, some technical comparisons. All these things I will going to discuss today's sessions. So now I'll come to that. Here in the last class, what I explained, the definition of embedded system. Now, how embedded system is different from general computing system. Sometimes may be called as differentiate between these two. Of course, during the examinations in the question paper, they're asking the question, it is like that. You should highlight the difference points by points. So according to the examination point of view, I'll prepare two columns. First one is general purpose systems. Second column is embedded system. Now we comparing with each and every parameters between these general purpose and embedded system. So now I'll come to the one by one. The first comparison from the general purpose system. In general purpose system, which is combination of generic hardware and general purpose operating system. But in embedded system, which is a combination of special purpose hardware and embedded operating system for executing a specific set of applications. So here, as per the definition, is very clearly it indicates that in embedded system, it performs a very specific application. But in general purpose system, executing a variety of applications for different applications. This is what the first comparison between these two. Now I'll come to the second point. So in general purpose system may contain general operating system. General purpose operating system. So here in the embedded system, they have used very specific operating system as per our requirement we are going to design. Suppose we cell phone, some kind of operating system. We have go to the desktop, some kind of operating system. In embedded system, suppose cell phone have particular applications. So the particular operating system we are going to choose because that it will be depends on our convenience. And in general purpose system, applications are programmable user. It is possible for end users to reinstall the operating system and add or remove user application. That option is available. But in embedded system, that is operating system like a firmware of an embedded system is pre-programmed and it is not alterable by end users. The user we can't alterable in embedded system, but general purpose system, the end user we can alter the system based on their requirement. They are going to alter it. That is what in general. But in embedded, it is specific. No, it is non-alterable by end users. For example, Linux is the operating system. VxWorks is the operating system. We have some set of standard commands also. Okay, that commands have to be understandable by programmers only. It's not understandable by the end users. The end users only to run that, to use that applications. Can't is difficult to alter. But now the option is not there. Okay. Now we'll come to the next general purpose system. Performance is the key deciding factor on the selection of system. Always faster is better. But in embedded system, the application specific requirements, they are the key deciding factors like performance, power requirement, memory usage, etc. They are the deciding factors. And the next comparison with respect to the general purpose system. So here the power requirement and options for difficult level of power management. The requirement of power and the options for different levels of power management. But here the advantage of power saving modes supported by hardware and operating system is available in the embedded system. And the response requirements are not time critical in general purpose systems. But in embedded system, for certain category of embedded system like mission critical system, the response time requirement is highly critical. In general purpose system, need not be deterministic in execution behaviors. But in the embedded system, the behavior is deterministic for certain type of embedded system like hard real-time system, or it may be a soft real-time system like that. We have specific means deterministic of certain type of system. This is what the general comparison between embedded system and general computing system. How embedded system is very different from general purpose system, only few words. In embedded system have very specific set of applications and proper functioning operating system. The end user not alterable, and it is very specific in with respect to the applications. You have this power saving mode supported by hardware and operating systems. Some hard real-time system also it belongs to that embedded system. Any real-time system without embedded system you can't achieve it. Like flight management system, satellite communications. Nowadays they are real-time systems. Without achieving the real-time system, the embedded system concepts. Okay, this is what the embedded system is better than general computing system. That is what I conclude from this slide. Now next, I will go to that some of the classifications of embedded systems. How embedded systems are classified? That is very important. The embedded systems classification based on some of the parameters. So what parameters to be considered here? The first parameters is based on generation. Second one is based on complexity and performance requirements. Third one is based on deterministic behaviors. And the last one is based on triggering. So what type of triggering it is? Time triggering or other triggering for that. So this is very important, the classifications. Anything in embedded system, if you want to classify it or if you want to explain the application of the embedded system with respect to the based on or domain based. Okay. Now I'll come to the one by one based on generation. Based on generation. This embedded system classification based on generation, you have sub 4 types. First generation, second generation, third generation, then fourth generation. What for these? In first generation, they started only 4-bit and 8-bit microcontrollers. This is what is called as early embedded system built around 8-bit microprocessor like 8085 is a 8-bit very popular microprocessor. And in the market, alternate one more process they introduced in the Zilog Z80. They are very popular during that time. These two microprocessors, both are microprocessors, but they are 8-bit process. And even small toys and all these things, they used 4-bit microcontrollers during that time. Means that during the first generation, 8-bit microprocessors and 4-bit microcontrollers, they are used during that time. And next, second generation. During the second generation, they advanced, little bit advanced. What they introduced in the first generation, 8-bit. Now here it is 16-bit process. And in first generation, 4-bit microcontrollers. In the second generation, they introduced 8 or 16-bit microcontrollers. That is what the next level of generation is, a second generation. In the second generation, the embedded system built around 16-bit microprocessors and 8 or 16-bit microcontrollers with the following the first generation embedded systems. In third generation, embedded system built around high performance 16 or 32-bit microprocessor or maybe microcontrollers, and introduce the application specific instruction set process like digital signal processing DSP and application integrated circuits. In the short form is called as ASCII, application specific integrated circuits. These are all things introduced during the year of or during the third generation. That is next, this third generation following the second generation. And the last fourth generation. In fourth generation, embedded system built around system on chip, SoC. And here one more, the important thing, reconfigurable process and multi-core process they used in the fourth generations. It means that in the fourth generation, embedded system built around system on chip, SoC, reconfigurable process and multi-core process. These are the classification based on the generation. Now I'll come to the conclusion from this slide. In first generation, 8-bit microprocessor and 4-bit microcontrollers. In second generation, 16-bit microprocessor and 8-bit microcontrollers. In the third generation, they introduced both 16 and 32-bit microcontroller applications and application specific instruction set like DSP, digital signal processing, and ASCII's application specific integrated circuits. In the last generations, that is called as a fourth generation, that is SOCS, and reconfigurable process and multi-core process. This is what the classification based on the generation. Now the second classification, I'll come to the second classification. It is based on the complexity and performance. So what for these complexity and performance? So here the first level of complexity and performance, small scale, medium scale, and large scale. What about small scale. In the small scale is nothing but the early embedded system built around 8-bit microprocessors like 8085 and Zilog Z80 and 4-bit microcontrollers. There comes in the small scale. And similarly, it comes to the medium scale. During the medium scale, now next, advanced with the first small scale, they are going to build around 16-bit microprocessor and 8-bit microcontroller following the first generation embedded systems. Okay, and the last one in the large scale or complex, as usual in the last slide, what I explained that it is fourth generations, third generations. All they are introduced. DSP, digital signal processing, application specific, integrated circuit, and 16 or 32-bit microcontroller. These are all the complex. Based on the complexity and performance, these are three classification. One is small scale, medium scale, and large scale or complex level. Then I'll come to the last two classifications. Classification based on deterministic behaviors, and similarly the same way classification based on the triggering. Both things will be highlighted in this slide. Here the classification is based on deterministic behaviors is applicable in real-time system. What is a real-time system? Any system responding at an instant, it is called a real-time system. Nowadays, the real-time system role is very important. Almost all the fields we are looking into the real time. But at the back end in the real time, supported by the embedded system, higher end embedded system. Higher end embedded system, for example, 32-bit microcontrollers like Cortex M3 or Cortex M7 processors, they are introduced. They respond very fast because they have higher end operating frequency. They have high operating frequency. The operating frequency is nothing but they have around 20 megahertz of operating frequency in ARM process, and they support for two modes. One is ARM mode, another one is a thumb mode. In the ARM mode, it support for 16-bit, and in thumb mode, they support for 32-bit. That is what they are become advanced. That kind of controllers they are going to use in any embedded system. That embedded system, it helps to the real-time system. That is what deterministic system behavior is applicable in real-time system. That is what it called as based on deterministic behaviors. And during the execution, behavior of embedded system can be either it may be deterministic or it may be non-deterministic. Example, in the general term, what we call as like a static or dynamic. Like that, we are going to decide it during the execution time. During the execution time, we look into that behavior of embedded system can be either in the deterministic or it may be non-deterministic. And the next will come to that based on the execution behavior in the real time are classified as hard real time or soft real time. Yes. Once come to the conclusion, it may be a deterministic behavior. Next level, it comes to the hard real time and soft real time system. What do you mean by hard real time system? Any system with a particular deadlines, that is called as a hard real time system. Example, flight is a good example for hard real time system. So no, without compromising the timing. Whatever the deadline is given, have to complete the mentioned deadline only, not before, not after. That is what? It is very important. It is odd real time. Restrict on to the time. And second one, it is called as soft real time. The soft real time is little bit flexible. May be complete before or after plus or minus 5 minutes or plus or minus 1 minute. That is what soft real time system. It's bit flexible. Maybe before or it may be after, based on the our complexity and the user speed. Everything it will be matters for that. But in not real time, not like that. You should stick on to that specified time. Okay. Now, then I'll come to that. Even though embedded systems which are reactive in nature. What do you mean by reactive in nature? These reactive in natures, this classification is based on triggering. The classification is based on the triggering in the embedded system which are reactive in nature, can be classified based on the triggering. Reactive system can be either event triggering or time triggering. What it means that? Event triggering and time triggering. So now first we have to decide it. If the embedded system which are reactive in nature, then only we can go for triggering. Event triggering and time triggering. Very simple here. Event triggering means, simple way it is, we stick on to the completion of work. Time triggering, so we have to wind up with the particular time. Either it may be completed or it may not completed, but you have to stick on with the time. But event triggering, you have to complete. The task is given. You have to complete it that specified work, and then you can leave. But time triggering is not like that. The work is completed or not, but you have to leave the specified time, punch time. Punch time means in time and out time. Here, they're not looking about to that work. They're looking only about to the time constraint. You can punch in, punch out. They are going to consider only these two things. What time is punched, what time is punched out. Punch in and punched out. But event triggering is not like that. Work-wise. You have to complete this task, you can leave. That is what. These two types of triggering is available, event triggering and time triggering. This is what the classification of an embedded system. So in the embedded system, so based on generation, first generation, second generation, third generation, fourth generation, based on complexity and performance, they are also here small, medium and large. Then based on the deterministic, it is hard real time or soft real time. Based on triggering, it is time triggering or event triggering. These are the classifications. Okay. So now I will conclude today's session. These are the content. In the next class, I will going to discuss about applications of embedded systems. Okay. Now shall I end up today? So next class, I will continue with the application of embedded